Okay, we'll do a quick review just of some concepts in this section. When we have two lines or two graphs, wherever the two graphs intersect is where we have solutions. So even if it's a funky looking graph, anytime two different graphs cross, those are solution points. Here we're just talking about lines, and so we have like two lines. Let's say they do this, okay? They cross in one point, they intersect in one point, so there's one solution. Now there's a word that describes that. When you have one solution, we say that that is consistent with having a solution. Okay, so we could call this a consistent system. Okay, and so sometimes you'll hear that word used in your books using that word here. Now what if we had two parallel lines? Okay, there are no solutions because those lines never cross. And in that case, we know these are parallel if that happens, if there's no solutions. And there's a word for that, and it's called inconsistent because it's inconsistent with having a solution. Okay, so you need to know that word means no solutions, and that word means we've got one solution. Now, what if you had another situation? What if you had a graph, and you graph the line, I'll graph it, and then you got another line and it's the same line, and maybe you realize it and maybe you don't, but if you were to graph it, it graphed right on top of that other line. Let me pick a green here, okay? So they're the same line on top of each other. They had infinite solutions because every single point on the line ended up being a solution. And we call those situations dependent. Dependent. The lines are so close to each other, they're dependent on each other. Sometimes we call this one over here that has one solution. Sometimes you might hear books call that independent, okay? But anyway, another term you might hear is if two lines are the same line, we might say it's an equivalent system because they have the same solution. So there's dependent. You might hear the words equivalent system to describe that. Okay. So let's look at some problems. I just kind of wanted to go over some terminology with you. We have done some different methods to solve these things. So if we have systems of equations, to solve system of equations, just another thing to remind you of some of the stuff you need to know, or you're not going to be able to interpret the instructions here. We solve systems by graphing and seeing where they crossed, okay? So that was one way we learned to do it back in Algebra 1. Another way we did was substitution, where we solve for one variable and stick it in the other equation. So you'll see us doing that today. And another one was linear combination, or the addition. Let's see, linear combination. It's so funny. This is the same textbook publisher that you had in Algebra 1, but in Algebra 1 they called it adding and subtracting equations. Okay. Sometimes it has all kinds of different names. So. Anyway, that's what we're doing in this lesson. Look at some problems. You kind of have to look at what you have to do, what would be the easiest method to use to solve some of these in 3.5. For example, if we are going to try to find the solutions for the written exercise problems, let's look at let's see, let me pick. I'm going to pick one that's not quite as straightforward and leave some of the easier ones for you to figure out. But you could always watch these to figure some of the easier ones out because they'll eventually end up looking like those. So on number 9, we have 3x minus 2y is equal to 0. And then we have a second equation. That's why it's a system. Remember, a system of equations means two or more equations. X plus 3y equal 14. Okay. Now, if you remember what we did with these things, we could use substitution here. It would be an okay method. And so, you know what? I may just pick it just because I can do it, okay? And I'll just use different solution methods. What I'm thinking here is I would do one of two things. I would either use substitution, and so that's what I'm going to show you here. And the reason I might choose that is that there's an x all by itself. So I could subtract 3y from each side and get the x all by itself, and that would be x equal 14 minus 3y. And if you remember what we did next, we took the first, if we used that equation to solve for a variable, we then go back to the other equation and we say, well, that's 3x minus 2y plus 2 is equal to 0. And I can take, what I can plug in for x is this amount right here. Since x is equal to that, I can stick 14 minus 3y in here. So that's what I'm going to do. I'm going to use substitution on this one. Another thing you could have done, if you remember, is linear combination. We could have gotten the x's and the y's on one side by themselves, and then we could put the constant terms on the other side, and then gotten the same number with opposite signs in front of a variable. And that's another thing you can do. I just chose not to do it here just because I wanted to have one where we could do substitution, just to remind you of how it worked. A lot of people liked this back in Algebra 1. Okay, so I'm going to have to simplify this and solve for y. 3 times 14 is 42. 3 times negative 3y is a negative 9y. Then I have a minus 2y, and plus 2 equals 0. All right, let's combine some like terms. I know that 42 and 2, if I combine those, that makes 44, right? All right, and then I'm going to combine some other like terms. We have y's here. Minus 9y minus 2 more y is a minus 11y, and that's equal to 0. Well, if I want to solve for y, right now my y is negative. I got to move a term to the other side. I might as well move the y term, because if the opposite of a minus 11y would be a plus 11y, and that would make everything positive, and I like that. I don't know about y'all. So we have 44 plus 0 is just 44, and 0 plus 11y is 11y. So to get y by itself, I could divide both sides by 11, and I get y equal 4. Okay, so if you remember how this goes, our answer is a point. It has an x and a y value to it, x part and a y part. And we just found the y part was 4. Now we need to find the x part. If you don't remember how we found that, what we did is we took the y and we or whichever one we had solved for. In this case, we did the y. We plug in y to find the x that goes with it, okay? What I'm going to do is I'm going to come over here, and I could plug it into either equation, but if you look right here in the blue equation that I had, that was a great place to figure out what x is, because it is x equal 14 minus 3y. And what was y? It was 4. So this is going to be pretty easy. 14 minus 3 times 4 is 12. And 14 minus 12 is 2. So my x is 2 when my y is 4. And that was my solution. Okay, we'll go ahead and try. I thought we'd look at number 19. I could use substitution on this one, but what I'm going to choose to do is the other thing, just to remind you of the different solution methods we had, is linear combination, or adding and subtracting equations. Now, I don't know if you remember this, but when we did this back in Algebra 1, one of the things that we did was to go ahead and put them in standard form, because that was easier to mess with them that way. And these equations are a mess anyway. No, somebody's got a bunch of stuff and they didn't clean it up. So let me look at my first equation. I'll call that equation A, just so you know what I'm talking about, okay? So in equation A, I'll do it in green. Okay, so A is green. Okay, I've got x minus 2y. X minus y is 2x minus 2. And what I'm going to do is I'm going to collect all my x's and y's on the left-hand side. So to move my 2x over here, I will subtract 2x. Remember, this is a 1x. 1x minus 2x is a negative 1x. I can put that there if I want to. I don't have to. And then I have a minus y equal negative 2. Now, I'm going to do the same thing with the other. Normally, if I were to put this in standard form, I'd be all picky about the x being positive. But you know what? I'm just going to be adding some equations together here in a minute. If you remember, we put them in this form, and then we try to find a way to add them together to get one of the variables to go away. So I'm not even going to bother cleaning that up unless I just have to, okay? Because I'm just going to work with it. I'm not trying to make the math police happy here. All right, so I have x plus y is equal to 2y minus 2 for that second equation, which I've labeled B. And so if I want to get all the variables on one side, I could subtract 2y from both sides, and that would move that over here. And so I'd have x, and I've got a plus 1y minus 2y would be a minus 1y. I'll go ahead and write that in there just because I can, okay? And then 0 minus 2 on the right-hand side is negative 2. If you remember what we did next, we took these equations and we I could put a 1 there. I'll go ahead and put the numbers in just in case you're having a hard time remembering this. And then I have a 1, for that purple equation B, I'll put the 1 in front of it. Plus 1x minus 1y is equal to minus 2. Now, if you remember the whole point of this, it was to be able to add it and get one of the variables, either x or y, to add up to 0. And if it doesn't happen, I have to make it happen. Well, it happens automatically here, because a negative 1x and a positive 1x adds up to 0. A negative 1y plus a negative 1y would be a negative 2y, and negative 2 plus negative 2 is negative 4. So in order to get y by itself, all I got to do is now divide both sides by negative 2. And a negative divided by a negative is a positive, and 4 divided by 2 is 2. Now, if you remember, my answer is a point. It has an x part and it has a y part, just like the first one. And my y here is 2, and I need to find the x. So let's go find x. Let me do that in black, just so that it sticks out a little bit, since I'm having to use every bit of my pad here. It's kind of hard to go to a new slide. I can't go back and look, and so it's always easier to work with the information in front of my face, just so you know why I'm not trying to, go and get a new slide. If I want to find x, what I could do is pick either equation and plug in the y. What I'm going to do is I'm going to pick equation B, and the only reason I'm going to pick it is because look at all these y's in that one. If I'm going to plug it in, at least I'm not going to have a whole bunch of x's left over to kind of have to put together, is what I'm thinking. All right, y was 2. So plugging in x plus 2. There's a y on the other side. 2 times y is 2. So I have x plus 2 is equal to 4. 2 times 2 is 4 minus 2. So I have x plus 2 is equal to 2. And you can see the answer is going to be 0, but we'll go ahead and subtract from both sides. We get x equals 0. So the x that goes with y equal 2 is 0, and there's my solution point. And just to kind of use the terminology, we would say that this is a consistent equation because it has an answer. It has one answer. Sometimes we call this independent because it has one answer. But this is just two lines that are going to cross in one point.